In this episode, we're going to be looking at adding and subtracting fractions. Hi boys and girls, in this lesson we will test our knowledge of adding and subtracting fractions. We will recognize and name equivalent fractions and solve single step and multi-step practical problems involving addition and subtraction with fractions and mixed numbers and express answers in the simplest form. Now it says here we need to examine this diagram and then use it to answer the questions that follow. So here we have tomatoes, we have red peas, we have peppers, green beans, lettuce, onions, cucumbers, squash, and corn. Okay. Question 1. What fraction of the garden is planted with each type of vegetable? And here we have the list. Now in order to do this, we'll have to compare each section. All right. So here's another way of looking at that. So we have this garden here. The quality is not the same in terms of the image, but you get the general idea. So we're going to see if we can add a line segment and we're going to divide it because we're comparing all these sections. All right. We have to find a way to make them equivalent. All right. So I'm going to continue this line all the way up, splitting it in two here. So let's see if we can get that line. Okay. So we see. All right. Then I'm going to get this line as well. So here we have this. And that's good. So I'm going to think that another one could come somewhere here. Somewhere about there. Okay. And then we're going to continue now and see if we can complete one here. This is horizontal. All the others were vertical. And that looks about it. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So the garden is divided into 20 pieces. Now the tomatoes would have 1, 2, 3, 4 pieces out of 20. And the red peas would have 1, 2, 3, 4 pieces out of 20. The peppers would have 1, 2, 3, 4 pieces out of 20. So look at this arrangement here. This is 4 pieces out of 20. This is also 4 pieces out of 20, but the arrangement is slightly different. The green beans would have 1, 2 pieces. The lettuce 1, the onions 1, squash 1, corn 1, and the cucumbers 2 pieces out of 20. So going back now, it says what fraction of the garden is planted with each type. We know that for the tomatoes we have 4/20ths, right, as a fraction. For the peas 4/20ths. For the green beans it would be 2/20ths, so 2 parts out of 20, right? So if we split this part, we have 2 parts out of 20. For the peppers it would be 4 parts out of 20. The cucumbers as well, 2 parts here. The squash 1 part, the corn 1 part. So that is how we would answer question 1. All right, let's see if I can make this a little bigger for you. So that's how we'd answer question 1. Now question 2. Farmer Brown wants to fertilize exactly half of the garden today. What combination of vegetables covers exactly 1/2 of Farmer Brown's garden? Show your working below. So another way of looking at this would be we have 4 out of 20, 4 out of 20, 4 out of 20, 2 out of 20, 2 out of 20, and then 1 out of 20 each for these sections. So let's look at if we have the whole. We have 4 and 4, and that would be 8. 8 and 4, 12. 12 and 2 would be 14, right? 14 and 2 for the cucumbers now, that would be 16, 17, 18, 19, 20. So this shows that we have the correct bottom number of 20, and we can show how each part or each section of the garden is divided appropriately. So we have found the what? The equivalent fraction for each part of the garden. So for the tomatoes, we have 4/20. For the peas, 4/20. And then now we need 2/20. And I'll take this one that's here, which will be the green beans. So we'll 2/20. And if we add all of these, we're going to get 4 and 4, 8. 8 and 2, we'll get 10/20. Number 3 asks us to find other combinations that would exactly cover 1/2 of the garden, and you can show that in the box provided here. So based on what we have so far, we have a half of the garden. So let's see, let's show the half of the garden that we have already. We have the tomatoes, we have the peas, and we have the beans. So if all of this is a half of the garden, let's fix this, then let's switch colors. Then all of this section would make the other half of the garden. So let's see if that is correct. So the peppers would be 4/20 plus the cucumbers, which would be 2/20, plus we have here the lettuce 1/20, plus the onions 1/20, plus the squash 1/20, plus the corn 1/20. And let's see, 4 and 2, 6, 6, 7, 8, 9, 10. So this would be 10/20, and that would be the other half. So here we have the first half with the tomatoes, the peas and beans, and this is how we could combine the other vegetables to come to another half of the garden. Number 4, if Farmer Jones needs 2/4 of a kilogram of fertilizer for the amount of lettuce he has, and 5 7/10 kilograms for peppers, A, how much fertilizer will he need in all? Show you working below. All right, so he needs 2/4 here, and then he needs 5 7/10. So he has 2/4. Let's switch this. He has 2/4, and he will add 5 7/10 to that. So we're going to add these together. Now there are different ways of doing this particular problem. We could add our whole numbers separately and then work on the fraction part, and that's the route that I am going to take now. But additionally, we could convert our mixed numbers to improper fractions and complete it that way. All right, so let's go. So we have 2 and 5, so 2 plus 5 would give us what? 7. So I have 7 whole. So I'm going to work now on the fractions, which will be 1/4 plus 7/10. The LCM here, 20, and 4 into 20 would go 5 times. I'm going to use that 5 and multiply by the numerator there. So 5 times 1 would give me 5, and that answer will come here. 5 plus 10 into 20 would go 2 times, multiply this, so this section here, and then this answer would come here. So that would be what? 2 sevens would give us 14. When we add 5 and 14, we would get what? 19 over 20. Remember, we had our whole number, so now this becomes 7 and 19 over 20. So that's method 1. So we have 2 1/4 plus 5 and 7/10, and now we're going to go to changing our mixed numbers to improper fractions. So 4 2's 8 and 1, this would be 9 over 4, plus we have 5 here, 10 5 50, and 7 57 over 10. All right, now we're going to find the LCM, which would be 20. 4 into 20 would go 5 times. We multiply that by the numerator, and then now 5 9s would give us 45, plus, and 10 into 20 2 times, so this would be 2 times our 57, and 2 7s would give us 14, would carry our 1, and 2 5s 10 and 1 11, so we have 114 here. Let's go with 114, and we're going to add 45 to that. So if we have 114 and we add 45, we're going to get 5 and 4 9, 4 and 1 5, and bring this 1, so we end up with 159. Okay, 159 over 20. And now we need to see how many times 20 could go into 159. Now we know that 20 can go into 105 times. 5 times 20 is 100, so 6 would be 127, would be 140, 8 would be 160. That's too much, so we have to stay with 7. Okay, so 7 here, and this would bring me to 140. I'm going to subtract. I get 9, I get 1. Now I can stop here. This is my whole number. So 20 goes into 159 7 whole times. I have a remainder of 19. This becomes my numerator, and my divisor becomes my numerator. So here's my answer, 7 and 19 over 20. And that was the same thing that we got here, 7 and 19 over 20. So if I go the method of adding my whole numbers first, and when working on the fraction bit, I will get the same answer as in method 2, where I convert my mixed numbers to improper fractions and solve. So I hope we're clear on that. It says here for B, how much more fertilizer will you need for the peppers than the lettuce? And you can work that one out. How much more will you need for the lettuce than the peppers than the lettuce? So I'm thinking for that one we're going to need to do some subtraction. So it would be 7 and 5 tenths. 7 and 5 tenths, and we're going to take from that the 2 and a quarter. So in this instance, we're going to have 57 over 10 minus 9 over 4, again 20, and this will give us 10 into 22 times, and we know that 2 times this would give us 114 minus 45. So it's 114, and we're going to take 45 out of this. So we need, since 5 can't come from 4, take 1, we'll have 10 here. This will be 14. 5 from 14, no, this will be 9. And 4 from 10 would be 6. Let's see. So if we have 69, how many times could 20 go into 69? we could work this out as a long division. So 69, 20, 20 could go into this 3 whole times. 3 sets of 20 would give us 60 remainder. So we have 3 whole times. My remainder becomes my numerator, 9 over 20. So in this episode, we looked at adding and subtracting fractions, and we were able to recognize and name equivalent fractions. So let's look at this. We know that 4 20th would be the same as 1/5. 4 into itself one time and 4 into 25, so this is 1/5. So wherever we see 4 20th, it could also be expressed as 1/5. When we were looking at a half of the garden, we know that 10 out of 20 or 10 over 20 is a half. If we divide the numerator and denominator by 10, we would get a half. So these are equivalent fractions. 1/5 is equivalent to 4 20th, and the half is equivalent to 10 out of 20. So continue going over the adding and subtracting of fractions. Go over the video as many times as is needed to make sure that you have this concept locked. Alright guys, take care, and I'll see you in the next episode.